Good morning to all. Myself, Dr. Arunaganya. I'm going to take one topic from third year subject. Subject name is CFD for Aerospace applications, and title is modeling conditions. So in that modeling conditions, what are all the conditions it will be utilized for CFD simulations? And the first one is the initial conditions. So in that initial conditions, they are using for steady or unsteady flow. So steady means it will be depend on the time, and unsteady flow it will not depend on the time. And that ICS flow, internal combustion flow, it should not affect the final result. So in that things, the number of iterations and number of steps it will be increased during this process. After that only we will get the accurate results from the given diagrams. And next one is the boundary conditions. So in that boundary conditions, we will fix the inlet and outlet of the given diagram. For example, you take one cylinder for this consideration. So here we will give the one side of the cylinder is input, other side of cylinder is output. So here we will give the blue color arrow, it will be indicate the input. Red color arrow, it will be indicate the output. So in that input, we need to give the inlet velocity, mass flow rate, pressure rate. For outlet conditions, we will give the constant pressure and velocity, outlet velocity, number of iterations, and what are all the gradients we are using. These are all things we need to give in that boundary conditions. Third one is the selection of models. So in the selection of models, it will be depend on the different type of flows, either viscous or invasive, turbulence or laminar, compressible or incompressible, single phase, multi-process. These are all the different types of models it will be utilized for this selection of models. So for turbulent and laminar, they are using the turbulent models. Incompressible and compressible flow, they are using the equivalent of state models. Single and multiple, they are using the gravitational two fluid models. Thermal density effect, they are using the conservation of energy models. Free surface flow, they are using the level state and surface tracking models. Chemical reaction and combustion, they are using the chemical reactions models. And next we are going to discuss about the turbulent models. So in the turbulent models, they are using the different type of modules like DNS, RANS, LES, DES. So in the DNS, we will get the accurate solutions from the Navier-Stokes equations, and RANS, the somewhat uh, accurate results will be given. Next one is a free surface model. So in that free surface model, it can be classified into two types. One is surface tracking method. Next one is a single two-phase level method. In surface tracking method, the is moving to the capture-free surfaces limited to the small and medium wave slopes. And a single and two level space set method, the mixes of two meshes, it will be reacted in that regions. This is the example for turbulent model. You see that figure. So the in figure 2, the mixes of two meshes, it will be found in that regions. And the next one is numerical methods. So in that numerical methods, the many initial boundary volume problems, it will be useful to solve the discretization problem. So discretization means that we will cut the one unstructured cases. So out of substituting structure into convenient number of smaller elements, that is called as discretization. So in that numerical methods, it will involve the following methods. Like first one is the discretization method. Second one is solver and numerical parameter. Grid generation and transformation, high performance computations, and post process. So in that discretization method can be classified into two types. So first one is a finite difference method, and second one is a finite volume method. So in that finite different method, they are using the regular meshing, and finite volume method, they are using the irregular meshes. So in the finite difference method, the spatial derivatives with the different order will be using for first order, second order equations are used in these cases. And for here they are using the implicit and the explicit process. So in that implicit, it will be there. You see the equations are taken from the Runge-Kutta method and Euler equation. And for the implicit method, they are getting the values from the Beam and Worm method.